This is the most insane construction job I've ever seen. A tunnel under a city filled with cars and water? Every day is a battle. Burst pipes, broken drill blades, even cave-ins are a constant threat.
Is that normal?
These working conditions are brutal. This is my kind of place. I'm here in Kuala Lumpur, the capital of Malaysia, home to the Petronas Towers, Asia's first mega skyscrapers. These two towers put KL on the map, and now the city's about to make construction history again. But this time, instead of going tall, they're going deep. This is the craziest construction site I've ever seen.
Until you got here.
Yes. Yes.
Meet Gus Claros, one of the world's top tunnel builders.
And I'm walking over a massive, massive hole in the ground. What is this?
We are at the north ventilation shaft. It's about 160 meter long, 25 meter wide, and 28 meter deep.
This looks like a set from like an Indiana Jones movie.
The project is called the SMART Tunnel, which stands for Storm Management and Road Tunnel. Here's the deal. KL is a city in crisis. Once or twice a year, two rivers to the north overflow and inundate the downtown, creating devastating floods. When the SMART Tunnel is complete, floodwaters will flow under the city instead of through it, and drain safely into a holding pond far to the south. The price tag? $250 million. And who's going to pay for this? Commuters. In the middle of the tunnel, a 2-mile-long double-decker toll road. Now, most of the time, water will flow under the road. But if a really massive flood slams KL, then both road decks will be evacuated, and stormwater will surge through the entire structure. It's the first ever dual-use storm and traffic tunnel ever attempted. But how do you drill a 6-mile tube 100 feet below the Earth's surface? Get yourself a couple of these babies. The biggest construction toys in the world. Tunnel boring machines. TBMs.
So can I drive the tunnel boring machine?
No.
Gus says that one of their 2 tunnel boring machines is down with a major mechanical problem. And the other TBM is inching through very treacherous ground. Beautiful. There is nothing like a crisis to bring out the best in a construction crew.
So now we're gonna go into the hole. I'm not a huge fan of heights, I should tell you. Not a huge fan.
Okay, well I can tell you that when you start, it will go off with a jolt, so don't worry about it.
Thanks for the heads up on that one. Oh my God.
It's about 100 feet.
It's like Journey to the Center of the Earth.
The ground above is dangerously unstable.
We're on the red train.
One mistake, or even just a little bad luck, and they could open a huge sinkhole right in the middle of the city.
It is so much more intense being down here than it is being up here. This is it? This is the...
This is where the controls is. So this is the logo operator.
How you doing? I'm Danny.
The tunnel boring machine is about 1.5 miles ahead.
Do you speak English? Yeah? No? All right.
The only way for me to reach it is to jump on board this underground train, used to carry workers and raw materials.
So this is where the water is going to be. The cars are above us, and this is the bottom of the circle.
1/2 mile in, I'm past the road building crews. And for the first time, I get the enormity of this project.
Wow, look at that. This is it. This is the whole tunnel now. You can see the whole thing exposed. The full cylinder.
Then, just ahead, the tunnel boring machine. This thing is an insane piece of engineering. Picture this, a 230-foot-long, 4-story, rock-eating submarine, as big as a 20-story building lying on its side, and heavier than a dozen 747s. The whole thing creeps forward through the earth behind a 40-foot-tall, rotating cutting face. And the kicker is, it also throws up row after row of waterproof concrete rings that line the tunnel. It drills and it builds.
So this is it. This is the TBM. This is the tunnel boring machine. And it looks like a building, a long building, but this is it. I'm physically on the machine right now. So up here is where they drive. This is the control room where they actually steer and control the pressure. Up here is an amazing piece of engineering. This is where they actually build the ring segments as they go. So right behind the cutting head, they're building the tunnel. And right there, that is the cutting head.
On the front of the cutting head, 72 steel cutting wheels.
What's so amazing about these cutters is, look at this, it's not sharp. This doesn't need to be sharp. It actually works on pressure from the TBM behind it, and it just rolls on the rock face and crushes it as it goes. Now the cutting face is located just beyond this wall right here, and it's a little bit deceptive because it's much bigger than that circle. It's not. It's actually 36 feet tall in diameter. So picture like 2 stories above me and 2 more stories below me. It's like the world's biggest drill bit ever. Come on. Oh. I forgot to wear my strong hat today. Oh, puppy!
In the control room, I meet Paul, a former rugby player from Australia. He manages all of the mining operations from this panel. But Paul's not happy, because the TBM can barely make progress.
So they knew they had a problem because they're typically going at about 20 to 25 millimeters a minute. Lately they've been going at 7. What does that mean? It means some of the cutter heads, maybe all of them, are either busted or worn or there's a problem with them. So they know they have to stop and check them. But they couldn't stop and check them because the ground they were in was too dangerous. It was soft, and to send someone in there, it was actually just too big a risk. You could have a cave-in, you could lose pressure, you could blow out someone's eardrums, or they could suffocate and die. So what does that mean, Paul?
We've just had a pretty big increase in the level. I mean, some material is coming in from the front.
So some soil, something from the earth.
Yeah.
A sudden inflow of loose earth, like a plug in a vacuum cleaner hose, has clogged the pipe that carries soil out of the tunnel. Paul wants to reverse the pressure to blow the plug out.
The pump's up.
But as he does so, a leak develops.
We're losing air.
Air must be leaking to the surface. A warning sign that the ground overhead might be giving way. What's worse is that the tunnel runs directly below a major highway. So a cave-in would be a double disaster for the tunneling crew and for the drivers overhead.
Pull up because we've got a lot of airflow.
The team struggles to push the TBM into firmer soil, but the problem grows steadily worse.
2.14. Yeah, 2.2 now. 2.5. She's dancing up and down, Dave.
It takes Paul 3 painstaking hours to inch the TBM forward less than 2 feet. Then, disaster.
Dave, are you there?
A massive sinkhole in the middle of the highway, directly overhead. We were 100 feet underground digging Malaysia's biggest tunnel when the ground gave way overhead. This is a major crisis.
All right, there is a big problem right now. The worst thing that could happen, a sinkhole. The TBM machine, when it was drilling, it got into some soft ground and created a cave-in. The traffic is stopped on the highway and there is a hole in the ground. Okay, so it's a little hard to tell, but that is one of the sinkholes made by the TBM below. They're filling it right now with the grout, trying to strengthen the surface. One of the biggest holes, come here, follow me, I'll show you, is on this side of the highway. And most of the damage happened right out here. If you have a look over here, you can see it's like an earthquake happened. It's like the ground has just been sheared off itself. Look at this, just a sheer cut in the ground right here. That's just the edge of what happened. Look at the side of that highway. The railing has just been ripped down, all that concrete destroyed. But in the center of the sinkhole, look at this. I should be standing on level ground right here. All of this ground has been depressed by this sinkhole, and right below me, 100 feet, is where the boring machine is right now. Nothing to see here. There's no sinkhole. There's no man-made small earthquake by a tunneling machine. Just a pothole, just routine lake. Come on now, keep it moving. Thanks, guys.
The sinkhole opened up when the TBM pushed forward into loose soil. As the earth gave way in front of the machine, the ground above just caved in. Now they're pumping grout, 100 cubic meters of liquid cement, into the soil in front of the TBM. The hope is that it will create a solid plug of artificial rock so they can get back to work. A stuck TBM is always trouble, but never more so than here in Malaysia.
When you're boring a tunnel, you actually use 2 tunnel boring machines. Why? Backup. Check it out. Typically, you cut 2 holes in the ground. One on one side, you span the distance of your tunnel, and you put your other hole here. One TBM goes in there, the other goes in there, and they come at each other. Now, why do this? If this guy gets stuck, this guy can finish the job and bail him out. Backup. In Malaysia, however, because Kuala Lumpur is so dense and so tight, they didn't have room for 2 holes. So, they'd put 1 hole in the center and set up both TBMs back to back and sent them off. The scary part is, if that guy gets stuck, there's no one to bail him out.
Bad as the sinkhole is, the road can be repaired, and the South Tunnel machine should be back in action before too long. But things are much worse in the North Tunnel, where the other TBM hasn't made an inch of progress in over a week. Robert hails from Germany and runs the North Tunnel crew.
Although it's very noisy, I don't hear the cutter head right now, is that right?
No. We have a breakdown in the moment, and we are repairing one of the most important parts of the machine, the stone crusher. Therefore, the TBM is now stopping for more than 1 week already.
The stone crusher is kind of like the jaws of life. But instead of saving people, it crushes rocks and makes them small enough to fit into the pipe that carries debris out of the tunnel. Sadly, it is not conveniently located.
About 2 tons in weight.
Rob, show me where the broken piece is.
The piece is here. This is just behind the cutter head.
So if that's the size of a person,
Yeah.
that is really tight in there.
To reach the rock crusher, we have to climb to the top of the TBM.
Oh, yeah, it's a little bit tight here.
The front of the machine is usually under pressure. The only way in is through an airlock.
So we're going into the airlock here.
So this is the airlock?
This is the airlock. It's a 2-chamber airlock.
Where do I pull the thing down where I can look and see the people on the surface?
No. The first chamber is just for safety. If someone collapses inside the airlock, that we can get him out. But after a while, the people get accustomed to this work. So you have to make some decompression. Same as diving.
Do people ever just go crazy in here?
Some people go crazy.
Sitting in this tiny airlock with Robert is unsettling. But it's nothing compared to the filthy hot pit he takes me to next.
So we are somewhere now at the center, and we go down now to the bottom part.
This is awful. So the cutter head is over there.
Yeah, somewhere there.
And why am I going down this hole? What's down there?
Down here, yeah. Okay, I go first. So we are now at the bottom of the TBM. We are just beside the stone crusher. We're going one last step down to the stone crusher where we are doing our repair work. We have to crawl over these pipes here. Huh?
Okay, you see these two pieces right here? That's the front of the bug's mouth. That's the pincer right there. This piece moves up, that piece moves up, and it crushes right there. Now what's busted is the piston behind it that lifts it up. This is the piston right over there. These guys are attaching the connector pieces, the joints basically that let the piston move up and down. So this thing will be, when repaired, clipped onto this thing, which pulls it up and lets it do the crushing. So right now it can't move. Did they draw straws for who had to go down there?
No.
Was he bad this week?
No, they're our best guys. Without these work, we cannot get the machine working. It's the most difficult place, the most awful work. It's quite difficult also technical-wise to perform the work right. So we have to get our best guys down in these holes and do it, yeah.
It'll be days before these guys get out of this nightmare. I would love to stick around and help, but there's just not enough room. This project just keeps getting more and more intense. Sinkholes to the south, claustrophobic pits to the north, and above, exploding rock 30 feet away from the highway. And me with my finger on the button. I'm in Malaysia, where they're building the first tunnel in the world that will carry both floodwaters and cars. And today, I get to blow stuff up. Road construction crews are already building the double-decker road inside the tunnel. And they're also excavating the on and off ramps outside. It's a dangerous job, right in the middle of a crowded city.
This is the South Junction box. Now what is that? The highway is there. The tunnel is 100 feet down there. So how do they get cars from the highway into the tunnel? With dynamite. Lots of it. If I play my cards right, I'm gonna blow some stuff up today.
The highway is less than 30 feet away from the pit. Any miscalculation could send solid rock raining down on cars and pedestrians.
Little rock climbing?
Yeah.
Guess they haven't built the stairs yet. All right, Mani, I'm Danny.
Yeah, I'm Mani.
How are you?
I'm okay, fine.
You are the detonation expert.
Yeah, not actually, so we are doing some blasting here. We are doing a control blasting.
Control blasting.
Yeah.
That's different from crazy blasting.
Yes, different. It's a quarry blasting. It's a different. In city, we are doing our control blasting.
Because we're in a city, you can't just blow things up.
Yeah, cannot fly the rock.
Can't fly the rock.
Figuring out how much explosive to use to blow stuff up is not always easy to do. And Mani has got the scars to prove it.
Yeah, I got one finger.
Wow.
Mani's goal this morning is to set off a controlled blast to loosen the rock below our feet. The night before, driller teams came in and poked about 80 holes into the ground, into which we're going to place about 1,000 pounds of dynamite.
This one is amolite.
This is the dynamite. This is what you stick the thing in.
Yeah, stick a thing. Then we put inside the hole.
Okay.
Okay.
Is this safe?
Okay.
Okay. You make a hole with that?
Yeah, make a hole like that. This is not. This one is explosive. I mean, this is it's a very danger. Just like this. Then.
How far down are we going?
4 meters.
4 meters, like 12 feet down.
Yeah.
What happens if you put too much of explosives? Okay. You got some dynamite? Oh, see that's the charger. That's the one that makes it go boom, right? It says danger, detonator, explosive, dangerous, blasting cap. Those are like 7 awful words.
Some more. More.
More still.
Yeah, more.
Is this safe?
Yeah, safe.
It's like making a bracelet, except of death. We're actually loading dynamite, but that's not enough. I have to be loading dynamite while I'm standing on dynamite. Okay, so So now we're going to insert the dynamite 4 meters into the ground.
Yeah.
A little more dynamite for good measure. Fire in the hole! Let it keep going down?
Yeah.
All the way down?
Yes, all the way down.
Okay, all the way
All
down.
the way down.
I'm just trying to let it down easy,
Yeah.
you know. It is dynamite.
Dynamite.
Yeah, this guy knows. This is... Okay, now we're going to tamp it down some more. Okay.
Monty assures me that the dynamite has been safely inert. Until now. They wire up the holes in rows. The first row will fire first, then the next row, and then the next row, and so on. The cool thing about these different delay times is that they allow Monty to sculpt his blast. Instead of one big boom, it'll move like a wave through the stone, which will reduce the vibration felt in the city.
This is okay?
Okay.
Get it in there. We take with us over there?
Yeah.
And we just...
Like,
So this is the last piece?
yeah, last piece. We're going to
This is
connect.
the electric detonator.
Yeah. Put a tape here.
Tape there.
Finally, the blasters cover the entire area. First, with heavy truck tires to absorb the shock, and then with massive steel plates to keep from flying the rocks, as Monty puts it. A siren warns everyone to take cover.
Okay, the chargers are set. We're about 30 feet from the pit. We're gonna blow the thing up right now. Monty, you ready to set it up?
Yeah.
Let's do it. So this is the detonator. So the wires are connected.
Yeah,
The-
wire is connected.
The charger's live right now. This is the key.
This is the key.
So the key is inserted. All right, all you have to do is hit fire and blow it up.
Yeah. Okay, fire.
Okay, it took a whole day to prepare for that one blast. So let's savor it.
So when the blasting is all done, they're gonna have brought a ramp all the way from up at the highway down here. This is basically where the vehicular part of the tunnel begins. That's just for water. And at this point, the cars continue on into the tunnel, into one of those 2 decks of traffic.
It'll take at least another dozen blasts to finish the job. The South Tunnel, though, is back in action. New cutting heads, firmer ground, their earlier problems are behind them. Now, Dick Potts and his crew are chubbing at the bit to make up for lost time. But as soon as they arrive, another setback. There's a slurry leak, and that is not good. This is the worst possible way for the crew in Malaysia's Smart Tunnel to start their shift. Slurry gushes from a burst pipe, and somebody's got to fix it. Fast.
What's going on then?
Well, we've blown a compensator.
A compensator is a rubber joint between 2 pieces of steel pipe. It may look like just one isolated part, but it is a crucial link. You see, these TBMs do not operate by themselves. They're actually connected to the world above by an elaborate supply chain that brings power, water, and other materials from the surface and pumps out all that tunneled rock. The fattest pipes on the machine are slurry pipes. Slurry is a mixture of water and bentonite, a mineral lubricant.
So this kind of milky, sandy, slurry stuff, this is what's in that tube. This is the bentonite slurry. That's right now it's leaking all over the floor. I mean, it's a dirty place when it shouldn't be this dirty. And this is what allows them to drill in soft soil conditions. They blow this stuff in front of the drill head, and it creates a pressure so they can actually push against it regardless of how soft or how problematic the surface they're drilling against is.
The geology under Kuala Lumpur is called karstic limestone. It's like Swiss cheese, a tunneler's worst nightmare. It's full of caves and loose soil. If the TBM pushes suddenly into an unstable area, the entire machine can be swamped by an underground landslide.
Okay, fellas. Quick.
The guys need to know why the connector ruptured. They suspect it was because of a pressure buildup somewhere in the supply chain. So I'm headed to the slurry plant, where the crew is frantically checking for problems. The slurry plant mixes water and bentonite lubricant, then pumps it 2 miles back to the cutting head. But the plant also receives used slurry, full of soil and rocks from the mining work. It dumps into the plant at the top and works its way down through a series of filters. If the slurry is not filtered properly, the line can clog, and that can blow out a pipe, creating the nasty mess I just came from back in the South Tunnel. Right now, the plant is idle, because engineers are concerned that somewhere in here, a broken filter may be letting pieces of rock into the mix. Until they know that the slurry is clean, this tunnel is going nowhere.
I'm in one of 4 filtering machines in the slurry plant, and right now we're gonna hop in and check the filters to make sure that no pieces like this are getting through to the boring machine. Right now, all work is stopped, so we have to check it quite quickly to make sure they can get back to work as soon as possible. Let's hop in. Hey, Mr. Chang, how are you? Is this your office?
Yeah, it's going to be my office now.
Mr. Chan is one of the engineers in charge of slurry production.
All right, how do I get in this thing? Okay. Okay. This is nice. This is nice. Okay, so this is the filter itself, huh?
Yes.
So what's the problem right now? What's going wrong?
Actually, during mining time, we found we suspect that there's some screen damage, is it broken?
How do you know that?
Because we see the flows is different.
So are pieces like this are too big? They shouldn't be getting through?
Yes, it shouldn't go through. Normally, this screen, this second level screen is only 4 mm in diameter holes.
So typically they're 4 millimeters, very small, and right now big pieces are getting through. Okay.
We flush slowly to the bottom chamber.
So we're flushing this down.
Yeah, flush it down.
So Mr. Chang is finishing up the work right now. We've blown out all of the small fine pieces. We're left with just the problem area. All of these rocks sitting right here signal we know exactly where the problem is.
Okay, you see we found the screen broken here.
Yeah, I can see it right here. There's
hole there, see quite a lot of.
Okay, so we found this filter. This one up here has got about, you can see 5 or 6 really big holes, like 1 inch by 1 inch. So the big issue is we got to get this filter out of there, replace with a fresh one, so they can start cleaning the slurry again and start boring again, because right now, nothing's happening. I come bearing reinforcements. Fung, you waiting for the new one, huh? Oh, here you go. There's the final piece that we can replace it with. Okay, so this is the busted piece that they just pulled out, and look at this. All of these were massive holes letting rocks like this through into the slurry, which shouldn't get through there. So we pulled it out, Fung replaced it with a fresh one and a clean one, and now the slurry machine can start producing slurry again, and they can start the boring machine again. So they've been down for 2 hours, it's a big deal. So let them get back to work.
If I'm quick, I can hitch a ride back into the tunnel before slurry floods the place. Back in Malaysia's Smart Tunnel, the day is half shot, and the guys in the TBM are still battling the slurry leak. Finally, the replacement arrives.
There it is. All that trouble over a tiny piece.
The chain's only as strong as its weakest link.
Okay, let's get this thing so you guys can get back to work. Just like changing a tire. Old goes out, new comes in, get back to work. Finished? Nicely done. Good work. These pipes here, when you want to get back to work? Yeah. So you can see them all.
Ralph, the driver on this shift, is ready to test the slurry system.
Okay, so that green light is from the slurry plant,
From the slurry
saying
everything is okay.
everything's okay?
I can start it.
So we can start the motor?
Yeah.
How do I do it? I give you slurry. Hey! that the shaking I'm feeling right now?
Yeah.
So the ground is, I'm sitting in the machine right now, and he's controlling how much of this slurry comes in. The whole room is shaking. A lot. Okay, not that much, but it's shaking. I mean, it's a vibrating room. I'm in a tunnel. So when do we turn the cutting machine back on?
As soon as I get the circulation over the slurry circuit.
And how long does that take?
That takes me 5 minutes.
5 minutes, and then you can get back to driving.
Yeah.
And smoking.
Yeah. Det är det jag shouldn't say.
The TBM is mining again, and that means that finally the guys can resume building the tunnel wall. Check it out. This place isn't some low-rent dirt hole. It's actually lined with high-strength concrete. Thousands of 5-foot-wide rings. This is the sickest part of this project. The TBM drills and builds at the same time. All day long, trains loaded with concrete segments arrive at the TBM. They're lifted into place by the TBM's vacuum erector. Sounds like something your spam filter's supposed to catch. I'm in luck. The South Tunnelers are just about to build a new ring using the most ridiculous remote control robot I've ever seen.
Okay. It's a vacuum erector. This is the control panel. Radio control, yeah?
So it's wireless, this thing.
It's wireless, yeah.
Can I rotate it?
You can, yes.
So I press it down to engage it.
That's correct.
And I pull it gently towards me.
That's correct. It'll rotate this way.
And it goes very slowly. If I go a little farther,
it'll go faster.
So I'll put it back straight now.
That's okay there.
It's okay? Okay. Okay, so now it's...
The vacuum on this thing is so intense that it can lift a 10-ton concrete segment. That's 20,000 pounds with the power of suction.
So you can move 10 tons in about 3 seconds using a joystick.
Yes.
It's kind of convenient like that.
Very handy.
The erector can rotate 360 degrees to place a segment anywhere, even overhead. And if the operator's good, he can position the segment within a millimeter.
So building a ring is just like building an arch. The glue that holds the whole thing together is the keystone up there. The vertical pressure from that piece gets transferred down the legs of the arch. In Malaysia, things are a little bit different. Here we're talking about a full circle comprised of 8 segments and 1 keystone, assembled very simply. Left piece, right piece, left piece, right piece, 5, 6, 7, and 8. And once they get that keystone up there, the thing is ready and can take pressure.
As each segment goes in, the guys have to race up and down this scaffold to install each piece. It is exhausting.
When it's securely held, and we're happy that it's not going to go anywhere, we release the vacuum, take off the erector.
Get the next one?
Get the next one.
One by one?
Yeah.
So how long does it take to put the entire ring on?
Half an hour.
Half an hour?
After 8 segments are in place, it's time for the final piece, the keystone. It fits perfectly, but the ring still isn't finished. For a final step, the team pumps grout into the gap behind the ring, cementing it forever to the rock wall.
The guys just knocked off the 1,400th ring. Now there's only 980 to go.
These guys call themselves the Lords of the Rings, and they have earned that title. Because the rings do more than merely line the tunnel. They also determine its direction. One of the more surprising things about this tunnel is its path. It follows a public highway. Why? Because in Malaysia, property rights extend to the center of the earth. You can't build a tunnel under someone's house. So how do you get a TBM to turn like a race car? Turns out, Gus has a trick up his sleeve. The Malaysia Smart Tunnel has to twist and turn as it carves through solid rock. Gus Kladosh shows me how it's done.
So what I don't understand is if you have a series of rings and they go straight, how do you turn when you have the same rings?
We have a trick, let me show you.
Okay.
This is a model what I brought in to show you how we do it.
Okay.
This is a model of rings built in the tunnel. The trick is, this red ring, you see how much thicker is on the right-hand side, on my right hand than on the left.
I see that.
And by rotating it, we can actually build one side of the tunnel longer than the other, so it turns to the other side.
Look at that. Look at that, is ridiculous. Look at that curve. I really like Gus's model, but for me, the best way to understand how those rings make this thing go up, down, left, and right is to think about a salami.
Imagine slicing a salami like so. With each slice, you want to angle your knife just a bit. Each slice now has a thick side and a thin side. Now, rotate the slices so that all the thin sides line up. Check out that curve. In the same way, the tunnel rings also have a thick side and a thin side.
Incredible, right? With just one angled cut to these rings, you can make the tunnel curve any way you want to. You want some cheese with this? Gus, can I give it a shot?
Sure, try it.
This is like a Rubik's Cube. I mean,
Yes.
so one goes there, one goes there.
Yep. Very
Next
good.
one there,
Very good.
next one there.
If you want to change your profession, I can have you as a shift engineer.
Beautiful. How do you guys pay?
Not very well, I'm afraid.
To really understand the process, it's good to think of it like feeding the beast. Every day, this big machine moves forward, and they ship in these ring segments. They cut some more, they build a ring. They cut some more, they build another ring. 2 days ago, that machine was standing right here, and all of that was solid rock.
When it's all said and done, there'll be more than 5,000 rings. That means nearly 50,000 segments, 500,000 tons of concrete and steel. This stuff.
This right here, this is rebar. And those incredible curved concrete segments are all getting their strength and their form from this stuff. Each segment has 600 pounds of rebar inside of it, and all the segments and all the rings are made right here by hand.
This is Eastern Pretech, one of 2 factories given the job to build thousands of ring segments. I'm up for a little bending and shaping. Somehow we have to get from this to this.
So this one we're doing 1 meter lengths.
Yep.
How do you cut rebar?
This has been pulled through into the bar machine.
You can cut 4 at a time?
Yep. Then he clips off the clamp.
Yeah, how much force is coming down on this thing?
It's about 2 tons.
2 tons of force. Okay, I'm gonna do it, okay?
Wow, sure, right.
Pulling it out?
Yep, that's how. Pull it out.
Pull it out.
Pull it out.
Oh!
So it shuts. That's it.
That is amazing.
Okay.
4 pieces are in there.
Oh. That's it.
Oh! Okay, so step 1 is we cut the piece.
Right.
What's step 2?
Step 2, it goes for rolling and bending.
Bending.
Right.
Well, I can save you a lot of time and money.
Oh,
Selva.
very good. We'll employ you there.
Let me just get my back into this.
Give it to me, Papa.
Okay, so I
Okay,
line
so
it up
you
with
hold
the
the
red
bars
line.
to the red line.
I screwed it up, didn't I?
Sudah lebih masuk.
You can tell me, guys. It's not gonna hurt my
No,
feelings.
the thing is, it was been stepped too much down.
I screwed up. You got 4 pieces in.
Yep.
Oh my.
So this forms the.
Workers assemble the rebar cage for each segment, 1 piece at a time.
So this acts as the skeleton, first skeleton.
I see. This is the skeleton of each piece. Okay, so what they're basically doing is just laying out the rebar, getting it into the frame, and they're gonna weld these joints together.
Yep. They first do the preliminary tying to hold the bars in position.
All right, here we go. And then, nope, missed that. All right. And okay. Yeah, he doesn't think it's okay.
This is much harder than it looks. Pouring concrete is easier and, frankly, more fun.
Hey! Okay, I am just topping off the last bits of concrete, getting it outside the edges here.
After drying for 24 hours, a vacuum lifter, just like the one inside the TBM, hoists the final piece and sets it aside.
So this is the end of the line. After the concrete is poured, it's set. They wait for 28 days for it to get to its maximum strength, and it's stockpiled right here, waiting for the TBM to keep on drilling.
All this stuff will end up underground. The goal is for each shift during a 6-day week to build 18 rings. That's 144 segments. But sometimes the guys do even better than that. In fact, one shift just set a new record.
I am thrilled to be here. I feel like you get to watch a Grand Slam. This week, Gus's crew did 31 rings, which is this is unheard of on this job. They're throwing a party for him right now and we get to hang out with them. Greetings. Is it a great shift, boss? Are they good workers? Is it luck? What makes it happen?
This is all together.
So basically, the stars aligned for these guys for 1 week.
Yes.
And they took advantage of it.
That's what happened. Listen, speech is coming. So, as we all know why we are here, in the last shift pattern you built 31 rings, and this is a record. And I congratulate you, and I would like to express the gratitude of the management. It's really an achievement, and I'm very proud of you. Thank you.
Cheers.
It has been insane living underground with these guys for the past couple of weeks. If they keep up their current pace, they're going to knock out this tunnel in less than a year. And they'll save a city by doing something that has never been done before: building the first dual-purpose road and water tunnel in the world.
Cool, I'm Danny.
Yeah.
Good luck, man.
Good luck.
Be careful. What's there?
It's quicker. Yes, that's it.
That was coming fast.